just make the bottom node ground. Is just usually what I do, and it works well here. And then remember, a node is everything that's connected together by a conductor without an element in between. So right here, that's a node, but it really means that everything here to here, here to here, here to here, all of that is a node up until you get to an element. So all of that is all at the same voltage. And I will call that, I'm going to call that V2. And this is another node, and I'm going to call it V1. No, I'm not. I'm going to call this one V1. I could call this one V0, but I'm going to call it something else. And I'm going to call it just 12.3, because I know it has to be 12.3 because the other side of it is ground. And I've found that that is actually something that a lot of Circuits 1 students are a little confused about, is how to read the voltage source, what it actually means. So for instance, if I had this circuit here, so I have this circuit, and this is labeled 6 volts, and while my handwriting is really bad, the left-hand side is negative, and the right-hand side is positive. So if I call this ground, what would I say is 6 volts?
The whole top wire after where the voltage.
Everything to the left of the first resistor on the right, or on the left. Everything to the right of the resistor on the left.
Everything to the right of the resistor on the left. Okay, so far I have not heard the right answer.
It's after the positive.
That's not it either.
It's only in between the points that it's 6 volts. Like from.
Well, if I'm labeling something,
voltage difference.
Yeah, 6 volts is so. Whenever we don't really use absolute voltages in electrical engineering. You might sometimes in physics when you say that, okay, I have zero potential at infinity. We only talk about relative voltages. The first thing I did was I put it in ground. Everything else in the circuit, if I label it, is relative to ground. What that 6 volt voltage source means is that the positive side is 6 volts higher than the negative side. That's what it means. So all I can say right now at this point is that if I call this V, then this is V plus 6. So I can't really label anything on here as 6. So nothing on here is exactly 6 volts. I just know that the positive side is 6 volts more than the negative side. And actually, if this were my circuit, I would probably do a supernode because I know this very fact. I know that I could do one, I could call this V1 and this V2, and I would know that V2 was 6 more than V1. And that would be one of my equations.
I'm a little confused at that. Wouldn't that make, so a question would be for V, would V be greater or less than ground? If it's going to be V plus 6 and then you have V, so would that make V 0 and then V is 0, then wouldn't it be equal to ground?
Well, I don't know what V is. I don't have anything marked on this. I don't know what V is. I don't know, if I put in some resistances, then I can solve for it, but V is an unknown right at this point. I can't say, I could, it's just like in the circuit that we're going to do here, where I have V1 and V2, I don't know what they are. I don't know what V is until I start to solve the circuit. And you certainly can have voltages that are lower than ground. Let's see, in this circuit, I don't know. I'd have to work it out and see. The probably so. It is probably true. V is probably lower than ground, but I don't know. If yeah, I'm not going to wait. I'm not going to waste y'all's time by just imagining things. But yeah, you could fill in. You could fill in some resistances, make them all one, and solve, and see what you would get. So, but the key thing that I'm trying to point out to y'all is that that's what you do with voltage sources. The Circuits 1 students are way too quick to say Ohm's law V equals IR and just find the voltage source and use that for V. And that is works in some simple circuits but doesn't work in other circuits. So you just want to be careful with that. All right, so now let's do the nodal analysis on this circuit that I have here. So what you do is you sum up all of the currents coming out of the node. So it doesn't mean that the currents are really traveling in that direction. That's just how we're drawing them for right now. We're going to take this current, and this current. And we're going to take all those currents coming out of the node. And whenever you are writing a current, the way you get the value of a current, any current, you're used to thinking that, well, V equals IR. But again, I'm going to caution you on that. That V in that equation is not an absolute V. That V is a difference in voltages. So whenever you have a current, it's going to be the voltage where you start minus the voltage on the other side of that resistor over the resistance. So when I'm taking the current coming out of V1 going to the left, that current is going to be V1 minus 12.3 over 10. And then when I take the current going down, that's going to be V1 minus 0 over 4. And when I take the current going to the right, that's going to be V1 minus V2 over 20. And that sum, that's going to add up to 0. I'm going to go ahead and simplify this equation before I get my second one. I'm going to multiply everything through by 20 to get rid of my denominators. So that would be 2V1 minus 24.6 plus 5V1 plus V1 minus V2 equals 0, which gets me 8V1 minus V2 equals 24.6. Does anybody see where I missed? Hey, I have that on my sheet from last semester. Cool. All right. Now let's get the equations for V2. So for V2, going up, I have V2 minus the voltage on the other side is 12.3 over the resistance is 5 plus going to the left, I have V2 minus V1 over 20. Now I often get a question, it's like, don't you have to worry about the stuff on the other side? It's like, well, the stuff on the other side, stuff is happening there. That is all true. But I'm just trying to measure the current right there. And the current between any 2 points is the difference in the voltage of those points over the resistance in between them. So I've gotten the value of that current. And then to the right, I have V2 minus 0 over 2, because that's ground. and then going down, because remember I'm getting all of my current coming out of the node, going down I have minus 2ix. And that all equals 0. So then, let's see, I will multiply this equation also through by 20. And I get 4v2 minus 49.2 plus v2 minus v1 plus 10v2 minus 40ix equals 0. And then simplifying that, I have minus v1, 4v2, 5v2, 15v2, plus 15v2, minus 40ix equals 49.2. Okay, so now let's go back and look at our circuit and look at what Ix is. Ix is the current going through this 10 ohm resistor. And remembering what I said about how you define the current, Ix is going to be the voltage on the side where it starts, which is 12.3, minus the voltage on the other side, which is V1, over the resistance in between, so 10. So 12.3 minus V1 over 10. So I can now substitute that in. Minus V1 plus 15V2 minus 40 times 12.3 minus V1 over 10 equals 49.2. And then if I simplify that, minus V1 plus 15V2, that would be a negative 4. So that would be negative 49.2 plus 4V1 equals 49.2. So then I believe I get 3V1 plus 15V2 equals 98.4. And then the other equation I got from my other node was 8V1 minus V2 equals 24.6. And then in my notes, it looks like at this point I did exactly what I'm about to do now. And it looks like last time I did this, I said, you really need to get a TI-36X Pro because it can help you not make mistakes. And at this point, I'm too lazy to solve this. So what I do is I get out my calculator and I solve it on my calculator. So I go to second and system solve 2 by 2, and I had 3 plus 15 equals 98.4. And 8 minus 1 is 24.6. solve. And I get 5.8 for y and 3.8 for x. So, and x was v1, so 3.8 for v1 and 5.8 for v2.
How did you get there again on the calculator?
How did I do that on the calculator? Do you have the TI 36X Pro?
Yeah.
Yeah. So what you do is you go to second, and it's the tangent button is System Solve, and it was a 2x2, so I chose the 2x2, and then you just put in the coefficients and the sign, and then go to solve. And it gave me the answer as a fraction, and the little button above the enter button will turn things back and forth between fractions and decimals. All right. And then what did the question actually ask for? To determine Ix. So Ix, we know, is 12.3 minus V1 over 10. So 12.3 minus 3.8 over 10. That's 0.5, 11 take away 3, 8.5 over 10, or 0.85 amps. Okay, any questions on that one? Yes.
So I noticed that even though there was a path of least resistance, not all the current went through that. So, yeah, like you know where the 5 ohms is? It's less resistant than...
Less, but not none.
That's true.
Yeah, so that's what you want to look for, a short. All the current will go through a short. So if you have no resistance, all the current will go through. If you have a difference of resistances, so like let's say we had 5 and 5K, almost all of it would go through the 5. But here it wasn't that big a difference.
So if that 5 just wasn't there, it was just regular wire, we would just ignore
We wouldn't even have a
IX, right?
Yeah, well, if the 5 ohm was not there, so we'd be shorting out all of this stuff. So let's see.
IX would just turn into one of the parts of V2. Like it would just shoot up. Short.
All of this would be one node.
Okay.
Yeah. Yeah. Okay. All right. Any other questions?